Hello and welcome to the Volkswagen TV training. It's nice to have you tuned in. Today we will talk about the Touareg 4Motion, but not only the Touareg 4Motion, but also about the Touareg 4Motion. Do you know the difference between these two drive concepts? Honestly, I didn't, but I know who knows it. Our trainer, Carsten Oehlmann. Welcome.
Hello, welcome.
Carsten, let's not delve into too much detail in the beginning. The terms 4Motion and 4Motion are relatively similar. Where is the technical difference?
4Motion refers to four-wheel drive in a Volkswagen in general, but there are different technologies available depending on where the customer wishes to use the vehicle. The new 4Motion has a self-locking centre differential. Thus, the vehicle is suitable for customers who predominantly wish to travel on sealed roads, but still it's a fully off-road capable vehicle. The X of 4Motion is the cherry on top in terms of four-wheel drive. 4Motion is the drive concept of the Touareg 2003 and can be ordered as special equipment. However, this may be different from country to country, so look at what is available in your country.
It is just like with clothes sizes, where XL is larger than L. 4Motion offers more four-wheel drive than 4Motion. But from a technical point of view, where is this cherry on top?
Well, the 4Motion features a centre differential with a reduction stage and a transfer box with a central differential lock and a rear axle with an axle differential lock.
Apart from that, everything remained the same?
No, we have a different torque distribution from the Touareg 2003. The differential's basic torque distribution between front and rear axle in the Touareg 2003 was 50-50. With the Touareg 2011, we have a torque distribution of 38-62. This was made possible by a smaller pitch circle diameter of the sun gear in the planetary gear set.
The 4Motion features a self-locking differential with a planetary gear set. How is this designed?
Let's have a look at the basic design of the planetary gear set. This is the planet carrier with the planet gears, and the sun gear and the rotor wheel. This is a third-generation torsion differential. Within the centre differential there are friction plates. Two are visible here in this cutout section on the graph, and two are on the other side of the housing. They are made of nickel-plated steel, and the friction plates, as well as the ATF oil used for lubrication, have an effect on the friction torque and affect the locking rate of the differential. Hence, it becomes clear that the ATF oil is also of vital importance to this gearbox, just as to any other gearbox.
Talking about friction torque, how is that created?
It is created by the locking effect of the helical toothing of each gear of the gearbox, and also by the pressing force of the sun gear and rotor wheel to each friction plate.
A total of 4 friction plates are contained in the center differential. How are they distributed?
Let's turn to this exploded view, which provides a clear overview of the components. There is one friction plate between housing and drive hub of the rear axle. The second one is between the planetary gears. The third is between the planetary gears and the sun gear. And the last is between sun gear and planet carrier. This is the top view, where we see how the torque is distributed. This is the sun gear with a small pitch circle diameter, resulting in a short lever arm and thus a lower torque towards the front. And then we have a large rotor wheel with a longer lever arm translating into a higher torque towards the rear axle.
Let's now deal with the advantages of 4Motion. These become particularly evident when the road surface or conditions change. On roads covered with ice or snow, even sand for instance, one axle might have a good grip, the other one a poor grip. Carsten, what happens in such a situation?
Well, if the wheels start to spin, the self-locking effect of the centre differential is activated. The drive torque will be redistributed to the other axle, which has a firm grip on the surface. However, a certain support force is necessary for the self-locking effect to be activated. As we see in the images here, the Touareg is driving on a sandy surface, quite a loose surface, so it might well be the case that one axle started to spin and the vehicle got stuck. Here, we see how the front axle of the vehicle even loosens its grip. The front wheels are running the risk of spinning, but still the vehicle is driven by the rear axle to prevent it from getting stuck.
Let's have a closer look at this locking effect and at how the drive torque is then redistributed.
Here, it is shown what its redistribution looks like. There are 4 time sections, T1, T2, T3 and T4. First, the Touareg drives on level dry surface, before the front axle drives over an icy surface, followed by the rear axle on the icy surface, and finally it has passed the icy section. This column represents the torque, a maximum torque of 1000 Newton meters with this vehicle, for example. On dry level roads, these 1000 Newton meters are the sum of 600 Newton meters of the rear and 400 Newton meters of the front axle. Now, the front wheels of the Touareg get to the icy surface. They are prone to spinning, but still, our total drive torque of 1000 Newton meters is maintained. This is due to the fact that the torque of the rear axle, which is still on the dry level surface, is increased, and the torque of the front axle on the icy surface is decreased to roughly 250 Newton meters. The sum of front and rear axle torque is still 1000 Newton meters. The driving energy is 100%.
Is there a speed differential between front and rear axle?
No, as long as the vehicle is going straight, there is no speed difference. Only the torque distribution is different, within the locking range. So, we have a 100% front drive in this case, and the electrical differential lock EDL does not have to be activated.
That much for T1 and T2, whereas T2 was with the front axle on icy and the rear axle on normal surface. But the Touareg continues to drive, and eventually the front axle will be back on a surface with normal grip, and the rear axle gets to the icy or snowy part. What reaction can we expect?
As we see on the graph, the rear axle is now on the icy surface. The total drive torque is now reduced. This is due to the fact that the rear axle, which is now on the ice, lowers its torque to roughly 250 Newton meters, while the front axle increases its torque but only to 600 Newton meters. This is due to the fact that we still need a certain reaction moment for EDL, the electrical differential lock, to be activated, and to lock the rear axle slightly to attain this reaction moment. Due to that braking action, we see a loss of drive. Thus, only 85% of the driving torque is available in this case.
Let's now talk about what's at the heart of the self-locking differential, or that's at least how I would refer to this transfer box. That's probably not too long a shot.
Yes, this is the self-locking differential, and it's within the housing of the transfer box. I'll explain how it is placed in the vehicle. This is where the vehicle bottom would be, so that would be the position of the transfer box in the vehicle. This is where the gearbox flange would be, where the transfer box is flanged to the automatic gearbox. So here, the power enters the transfer box and passes the third generation torsion transfer box. This is the connecting flange for the prop shaft of the rear axle, and here, the prop shaft of the front axle is flanged to the transfer box.
There are different engines available for the Touareg, different engine versions. Can we use the same gearbox for all engines?
Basically, yes. Of course, there are different transmission ratios according to the engine model, and naturally the dimensions of the transfer box vary. This neck part is shorter or longer depending on the engine model.
Let's turn to how the power is transmitted in this transfer box.
Well, I've opened the housing already, so I'll now tilt it for you to see the input shaft of the transfer box. Now we see what's inside the gearbox. Here we see this hollow shaft, the input shaft. It's a hollow shaft. The power will be transmitted directly to the planet carrier of the Torsen transfer box. In top view, we see the chain drive that drives the front axle. Thus, the power that is transmitted to the transfer box will be passed onto this chain and to the front axle. This is how the power is distributed to the rear axle, and via this chain to the front axle.
The next element of interest is the planetary gear set. This brings us to a moment that you are familiar with Volkswagen TV trainings. You get to see things that you would never see in your everyday workshop life otherwise. We already showed the planetary gear set as a graph, but of course it is always more fascinating to have a hands-on look at the real component.
Absolutely. So I removed the drive chain and everything else that is in the way of the Torsen transfer box. Now we see where the Torsen transfer box is mounted, directly below the output gear of the prop shaft towards the front axle. It's just put on here, so I simply take it out. There are several bolts which connect it. Naturally, I will have to remove these bolts to disassemble the gearbox.
Usually, of course, they would be tightened to a much higher tightening torque. But as has been mentioned, with Volkswagen TV you get to see things that you'll never see in your daily life. Plus, what if a mechanic were to disassemble a Torsen transfer box? Then you basically can't use it anymore, right?
Correct. You must not disassemble a Torsen transfer box, as there is no repair manual for such an action yet. As you know from market introductions, you always have the obligation to issue a notice before any repairs or replacements, and may only replace or repair the part after having consulted the TSC. So far, the release of a repair manual hasn't been planned, but may well happen in the near future. Of course, I don't know how that might look.
So this Torsen transfer box may serve no other purpose anymore than being looked at.
Absolutely. This is the Torsen housing, and what we are not yet able to see is the planet carrier. This is the first friction plate, which acts like a support for the housing of the rotor wheel. This is the rotor wheel. Another friction plate becomes visible now. This is a connecting flange, a further friction plate, this is the sun gear, and from this top view we now also see the planet carrier, with all planetary gears that are mounted in here.
Now we will get to the lubrication circuit of this transfer box. Two things are striking and new in this respect. Firstly, ATF oil is used now. Secondly, lubrication as such has changed.
We do not use a separate oil pump for the oil circuit anymore, as this chain, drivetrain chain towards the front axle, also carries the oil towards the transfer box and the upper shaft. You'll be able to recognize it better on this graph, as only the components involved in the oil circuit are displayed now. Inside the transfer box is an oil sump, and due to the rotating movement of the drive chain or the driving wheel, the oil is transported up to this oil drip pan here, before it is then led to the upper shaft. Due to the centrifugal force of the transfer box, the oil lubricates the transfer box, even in the upper section. Let's turn to the transfer box as such once more, to see how it actually works at the real component. The chain is led around here, in this area from the upper shaft to the drive shaft. And here we see this black guide bar that is responsible for the oil circuit. That is how the oil enters the plastic housing to this shaft, and due to the centrifugal force, it starts rotating and will distribute itself in the transfer box.
So the oil only moves when the chain is rotating as well. Hence, we need a propelling movement. As of what speed is sufficient lubrication for the transfer box provided?
Always. Already when driving at walking speed. It'll work even in reverse gear.
But what if the vehicle is at rest, the chain doesn't rotate and no oil is transported?
The oil circuit as such comes to a halt. However, the inner lubricating points remain in contact with oil, and thanks to the construction of the differential housing, a certain amount of oil will always be retained in the housing, which is caused to move by centrifugal force as soon as the vehicle starts moving, ensuring permanent lubrication.
Now we will talk about how the transfer box is mounted in the Touareg. Usually prop shafts are connected to a gearbox using bolts, but here this has been solved differently.
Yes, instead of bolts there is a spline connection now between transfer box and prop shaft on the front and rear. We're looking at the bottom of the vehicle. This is the transfer box, this the prop shaft towards the front axle, and this is the prop shaft towards the rear. Let's see how we can remove the connection between the prop shaft towards the rear and transfer box. Put an assembly lever between absorbing weight and gearbox housing. We'll fade that for demonstration purposes, and with a strong movement of the lever, separate the transfer box from the prop shaft.
Why did the connecting principle change?
The main object was to reduce weight, since larger drive flanges meant a weight increase there. Using a spline helped reduce weight at other points instead, and mounting and removing has become simpler as well.
Talking about mounting and removing, when mounting the transfer box, a replacement might be due as well. A sealing ring, for example?
Yes, that's a good point. At the spline there is a sealing ring insulating the spline towards the prop shaft. Always replace this sealing ring to avoid either dirt or humidity entering this spline to prevent corrosion. Furthermore, this securing ring might have to be replaced, as it might loosen its pre-tension, which of course is vital for a safe mounting and correct positioning of the prop shaft.
Let's now focus on the technology of the 4Motion, which has been adapted from the previous 4Motion. Of course, some minor changes were necessary to make the components fit to the new engines. However, it still features a center differential with an electrically operated lock and a reduction stage. This has remained the same. However, could you please outline how 4Motion works?
First, this is the reduction stage. It contains a planetary gear set that can be connected and opened, providing us with a transmission ratio of 2.7 to 1. So axle speed is reduced and torque increased. This external electrical motor activates the cam plate here, and the inner cam track operates the selector shaft connected to the selector fork. The locking collar, which is selected, is the hollow gear of the planetary gear set at the same time. Thus, two different sets of planet carriers can be connected, and for smoother shifting, there's a synchro gear.
What does central differential lock actually refer to?
It's this longitudinal lock. It features a multi-plate clutch driven by an E-motor. The latter also activates the cam plate inside the transfer box. Now, the outer cam plate is used to operate this relay arm, which in turn presses on the lamination via the engaging plate.
But the central differential lock is not activated permanently.
Yes, it depends on driving behaviour. Drivers have to activate it themselves. Behind the selecting motor there is a planetary gear set, and the torque that had been forwarded and calculated by the control unit can be set. This is done quickly and precisely. It is vital, of course, that the lamination works without slip. This is why there is such a high pressure on the lamination.
Let's take a look at the lamination of this transfer box.
Yes? I prepared this already, so I'll simply remove the output shaft for us to clearly see the lamination. On top, there is an engaging disc, operated by the relay arm. Thus, the lamination can be pressed together more or less firmly according to need.
With 4Motion, the drivers have to lock this lamination themselves. When does this offer an advantage?
If I drive on rough terrain, it makes sense to activate this lock. But drivers have to do that themselves, switching the knob on the center console. In the first position, they can reduce the transmission ratio. They can activate the central lock in the next position, and also the axle differential lock, after another turn of the knob.
Four-wheel drive is always referred to as 4Motion with Volkswagen. Now we have two versions of 4Motion and 4Motion. What makes the 4Motion so special? The self-locking center differential. Carsten, thanks a lot for presenting the four-wheel drive to us.
Thanks for having me, and goodbye to our audience. Have a good day.
And because we were helpful in your everyday work, click again on the next Volkswagen TV training. See you next time. Goodbye.